Good day, everyone. My name is Jeffin de la Cruz from STEM 11A, and today, I and my group mates will help you to understand and we will learn together about hyperbola.
But first, what is a hyperbola? A hyperbola is a curve that occurs at the intersection of a cone and a plane. It is also the set of all points of the plane such that the difference of their distances from the two fixed points foci is constant. The hyperbola has two orientation. It is the vertical hyperbola and horizontal hyperbola. This is the graph of the hyperbola when the center is at the origin and the orientation is horizontal. This is the graph of the hyperbola when the center is at the origin and the orientation is vertical. There are 5 parts of hyperbola, and these are center. This can be at the origin or H and K. This is middle innermost part of a hyperbola, foci, focus 1 and focus 2. Each focus is a C units from the center and collinear to the vertices. Vertex 1 and vertex 2. Each vertex is a unit from the center. Moreover, the transverse axis has a length of 2a. Endpoints of conjugate axis. Co-vertex 1 and co-vertex 2. Each endpoint of conjugate axis is b unit from the center. Moreover, the length of conjugate axis is 2b. Asymptotes. These are the two lines that intersect at the center.
Hello everyone, my name is Irene Medina from STEM 11A, and I will show you what are the different standard form of hyperbola. As my friend Hawin derived the formula of the equation of the hyperbola, now we know what are the standard form of the hyperbola, that the center is at the origin or H and K. So let us now know and differentiate the standard form of the hyperbola. And now we're going to identify the standard form of hyperbola. In horizontally center at the origin, we're going to use x squared over a squared minus y squared over b squared is equals to 1. And center at the h and k, x minus h squared over a squared minus y minus a squared over b squared is equals to 1. And again vertically, center at the origin, y squared over a squared minus x squared over b squared is equals to 1. Center at the h and k, y minus k squared over a squared minus x minus h squared over b squared equals to 1. Take note that in hyperbola, a is doesn't always greater than b. Just like in ellipse, it is either the a is less than or greater than b.
Hello everyone, I'm Omar from STEM 11A and I will show you how to derive the equation of hyperbola. So to start with the hyperbola horizontally, so we have these graphics here. So let us determine the parts of the hyperbola first. So we have here the foci, the vertices, and the co-vertices. The co-vertices wasn't really necessary, but we're going to put that there so we can have the equation of asymptotes. So the equation of asymptotes is y is equals to negative b is x, and y is equals to b over ax. So that's the equation of asymptotes when the hyperbola is horizontally. So we're going to derive the equation of hyperbola through this formula. So distance 1 minus distance 2 is equals to k. K is an unknown number, so we're going to find that out later. So distance 1. So as you can see, the distance 1 that I have made is from this point to this point. So I'm going to get the coordinates of that point. and put that there later. So this point here is from here. So distance 1 is c plus a, because from the foci to the origin, that is letter c. So from this point to this point is letter a. So this point to this point is c minus a. So let's put that here. So distance 1 is equals to a plus c, and distance 2 is equals to c minus a. So we're going to put that in this equation. So distance 1 minus distance 2 is equals to a plus c minus a, and that will be a plus c minus c plus a, because negative times negative is equals to positive, and that will be 2a. C minus c is equals to 0, so that's cancelled out. So as you can recall, our distance formula is square root of quantity of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So what am I going to do is I'm going to put the coordinates of the distance 1 there. So the coordinates is negative c, 0, and x and y. So let us put that here. So distance 1 is equals to the square root of x minus negative c squared plus y minus 0 squared. So that will be positive because negative times negative is equals to positive. So that will be plus. So distance 1 is equals to square root of quantity of x plus c squared plus y squared, because that is 0. So the only one that will be remains standing is the y squared. So distance 2 is equals to the square root of quantity of x minus c squared plus y minus 0. Same process with this one. And after this, we're going to put the values of distance 1 and distance 2 in this formula. So again, we're going to put that there. Substitute the values of distance 1 and distance 2. That will be square root of quantity of x plus c squared plus y squared minus square root of x minus c squared plus y squared is equals to 2a. So it will be complicated to remove the radical sign here because we have two radical signs on this side. So what we're going to do is we're going to transpose this one, the distance 2 to the other side. So that will be square root of x plus c squared plus y squared is equals to 2a plus square root of x minus c squared plus y squared. So this is negative on the other side, so it will be positive on this side. So in this way, we can finally square both sides. So that will remove the radical sign here. And as you can see, this is in the form of a plus b squared. And a plus b squared is equals to a squared plus 2ab plus b squared. And that will be remove the radical sign. So that will be quantity of x plus c squared plus y squared is equals to 4a squared plus 4a square root of quantity of x minus c squared plus y squared plus x minus c squared plus y squared. So we have here y squared had the same values, so we're going to cancel them out. So in shortcut, I have written this form here in an expanded form. So that will be x squared plus 2cx plus c squared is equals to 4a squared plus 4a square root of quantity of x minus c squared plus y squared plus x squared minus 2cx plus c squared. Again, cancel out the same values. That will be 2cx is equals to 4a squared plus 4a square root of x minus c squared plus y squared minus 2cx. So what we're going to do is we're going to transpose these two on the other side. So that will be 2cx plus, because this is the negative 1, minus 4a squared plus 4a square root of quantity of x minus c squared plus y squared. So I have combined these letters. So that is 4cx minus 4a squared is equals to 4a square root of x minus c squared plus y squared. So I have divided into 4, so this will be 1. So that will be cx minus a squared is equals to a square root of x minus c squared plus y squared. So I have written it in an expanded form, and this will square this one, and this will remove the radical sign. So c squared x squared minus 2a squared cx plus a to the fourth power, and a squared times x minus c squared plus y squared. And I have expanded this one and used the distributive one. I distributed this a, so there wouldn't be any remaining. So c squared x squared minus 2a squared cx plus a to the fourth is equals to a squared x squared minus 2a squared cx minus a squared c squared plus a squared y squared. So what I did is transpose this one to the other side and transpose this two to the left side. So I have combined the x and y's, as you can see, and that will be c squared x squared minus a squared x squared minus a squared y squared is equals to a squared c squared minus a to the fourth. So I have combined these two because they have the same value, which is x squared. So x squared times c squared and a squared, sorry, this one is minus a squared y squared is equals to a squared c squared minus a squared. So let b squared is equals to c squared minus a squared. So let us use this one. So substitute the b, that will be x squared b squared minus a squared y squared is equals to a squared b squared, and that will be that one. And we're going to divide this one to a squared b squared to itself so that it can be 1. So our goal is to make this part here equals 1. So divide to itself. We're going to divide this to the other side. We're going to do that in this one too. So we're going to cancel out the same values, and the remaining is written right here. So x squared over a squared minus y squared over b squared is equals to 1. So that is the standard form of hyperbola horizontally. So hello again, I'm going to show you how to derive the equation of hyperbola vertically. So what am I going to do is, so let us determine first the parts of the hyperbola vertically. So we have here vertices, we have here the cosines, and we have here the co-vertices. So in the form of, or the asymptotes in vertical is equals to y is equals to a over b x. So let us put the distance one here, on our equation here. So distance 1 minus distance 2 is equals to k. Again, unknown number. So distance 1 is equals to a plus c. It has the same process as the horizontal, but it has different, what do you call it? So we have different values. So our x and y's will be the point there. So distance 1 is equals to x minus 0 squared plus y minus c squared. So distance 1 is equals to square root of x squared plus y minus c squared. Our distance 2 is on the same process. That will be equal to square root of x squared plus y plus c squared, because positive times positive is equal to negative times negative is equal to positive. Sorry. So we're going to put the values of distance 1 and distance 2 on this formula, and I have written that here. So again, this is a complicated equation, so we're going to transpose the distance 2 on the other side. So distance 2 will be here. So x squared plus y minus c squared is equals to 2a plus, again, because this is negative side, square root of x squared plus quantity of y plus c squared. So this is in the form of a plus b squared. So a plus b squared is equals to a squared plus 2ab plus b squared. So this will remove the radical sign here because we have squared both sides, because we're squared here. So that will be x squared plus y minus c squared is equals to 4a squared plus 4a square root of x squared plus y plus c squared plus x squared plus quantity of y plus c squared. So again, I have done the shortcut form, or I have expanded this one. So y squared minus 2cy plus c squared is this expanded form of y minus c squared. So I have written that here. That will be equal to 4a squared plus 4a square root of x squared plus quantity of y plus c squared plus y squared plus 2cy plus c squared. So again, I have these two because they have the same value. So the remaining is negative 2cy, 4a squared plus 4a square root of x squared plus quantity of y plus c squared plus positive 2cy. So we're going to transpose this over here. So transposing the positive 2cy will be negative 2cy. So negative 2cy minus 2cy plus 4a squared is equals to 4a square root of x squared plus quantity of y plus c squared. So I have combined these like terms. So that will be negative 4cy minus 4a squared is equals to 4a square root of x squared plus y plus c squared. Again, divide it into 4 because you have to divide it itself to get rid of these values. So this have to be equal to 1. So negative cy minus a squared is equals to a square root of x squared plus y plus c squared. So we're going to square both sides, and that will be c squared y squared plus 2a squared cy plus a to the 4th power is equals to a squared x squared plus y plus c squared. Because we have square this one, it will be cancelled out. So c squared y squared plus 2a squared cy plus a to the 4th is equals to a squared, and I have expanded this form. That will be y squared plus 2cy plus 2c to this c squared, I mean. So c squared y squared plus 2a squared cy plus a to the 4th, and distribute it properly. So that became a squared x squared plus a squared y squared plus 2a squared cy plus a squared c squared. So again, cancel the same values. So I have put the x and y's here, the ones who had the x and y values. So that became c squared y squared minus a squared y squared minus a squared x squared is equals to a squared c squared minus a to the fourth over. So they both have the y squared value, so I put that here. So y squared times c squared minus a squared is minus a squared x squared is equals to a squared c squared minus a squared. So this 2 is the form of this. So let b squared be equal to c squared minus a squared. So I have written this one as this. So y squared b squared minus x a squared x squared is equals to a squared b squared. So we're going to divide it by itself, so it will be equal to 1. Our goal is to make 1. So divide it. Also do this method to the other side too. So the values here will be divided into a squared b squared. So cancel out the same values again. And the remainings will be y squared over a squared minus x squared over b squared is equals to 1. So that is the standard form of the hyperbola in a vertical form. Thank you.
Hello everyone, my name is Angel Joy from grade 11 STEM, and today I will show you how to transform general form to a standard form of hyperbola, identifying the orientation and center. Here are some examples of converting general form to standard form. This is horizontally and the center is at origin. 4x squared minus 25y squared is equals to 100. We transpose negative 100 to other side, so it will be positive 100. 4x squared minus 25y squared is equals to 100, then divided by itself. And 4x squared divided by 100 minus 25y squared divided by 100 is equals to x squared over 25 minus y squared over 4, so it equals to 1. Then let's proceed at the center of h and k. Example, 4x squared minus 5y squared plus 32x plus 30y minus 1 is equals to 0. Combine same variable, so 4x squared plus 32x minus 5y squared plus 30y is equals to 1. 4, then factor out this 4x squared plus 32x. 4 quantity of x squared plus 8x negative 5 y squared plus 6y is equals to 1. Then after that, we proceed to a step of completing the square. 4 quantity of x squared plus 8x plus 16 minus 5 quantity of y squared plus 6y plus 9 is equals to 1 plus 16 times 4 plus 9 times 1 negative 5. 4 quantity of x minus 4 squared minus 5 quantity y plus 3 squared is equals to 20. We got this 20 because 1 plus 16 times 4 plus 9 times negative 5 is equals to 20. Then let's proceed. 20 divided by itself again. Then x minus 4 squared over 5. We get this 5 because 20 divided by 4 is equals to 5. Then minus y plus 3 squared over 4. We get this 4 because 20 divided by negative 5 is equals to 4. So 20 divided by 20 is equals to 1. Now let's discuss about general form to standard form of hyperbola. Orientation is vertically and center at the origin. 16y squared minus 9x squared minus 144 is equals to 0. 16y squared minus 9x squared, let's transpose negative 144 in another side, then it will be positive 144. Let's divide it by itself. So 144 divided by 144. Then Then let's proceed center at H and K. Still vertically. So 16y squared minus 9x squared minus 32y plus 54x minus 209 is equals to 0. Let's just combine the same variables, 16y squared minus 32y minus 9x squared plus 54x, and transpose negative 200 in another side. So it will be positive 209. Factor out 16y squared minus 32y, 16 quantity of y squared minus 2y. Then let's factor out this negative 9x squared plus 54x. The negative 9 quantity of x squared minus 6x is equals to 109. Then let's proceed the step of completing the square. 16 quantity y squared, so it would be negative 2 divided by negative 2 is equals to 1. 1 squared is equals to positive 1. Negative 9 quantity of x squared minus 6x plus 9. 6, negative 6 divided by 2 is equals to negative 3. Negative 3 squared is equals to positive 9 equals to 109 plus 16 minus 81. So 16 because negative 9 times 9 is equals to negative 81. Then let's simplify. 209 plus 16 minus 81 is equals to 144. Then let's just divide it by itself again. So 144 divided by 144 is equals to 1. 16 quantity of y minus 1 squared minus 9 quantity x minus 3 is squared. Then let's just divide it to 144. So 144 divided by 16 is equals to 9. 144 divided by negative 9 is equals to 16. So let's just simplify it. Y minus 1 is squared over 9 minus x minus 3 squared over 16 is equals to 1. And that's how you convert general form to standard form of hyperbola.
Hello everyone, it's me, Myers, and today I'm gonna show you the standard form to general form of a hyperbola when it is horizontally. So let's start with the origin, 0 is 0, and the equation is x squared over 25 minus y squared over 4 is equal to 1. Okay, so first step, we're gonna put the equation here. That is x squared over 25 minus y squared over 4 is equal to 1. And then we're going to find the LCD, or the least common denominator. We're going to put it to the left side and right side. 25 times 4 x squared over 25 minus 25 times 4 y squared over 4 is equal to 100, because 25 times 4 is equal to 100. And next we're gonna cancel the same numbers like this, 25 and 25. So we're gonna cancel this one and this 4 and 4. So it will become 4x, because 4 times x squared is equal 4x minus 25y squared, because it is, we will write minus because it is negative 25. And y squared here is equal to 100. So it will become 4x minus 25 squared minus 100 is equal to 0. Now, we'll go to the standard form for general when we are center at H and K. And the example is quantity x minus 4 squared over 5 minus y plus 3 squared over 4. And then like here, we will just do the same process. Like this, we will find the LCD and we will do both sides. And we will multiply it here and this one to there, and then we will cancel the same digits or numbers. So it will become 4x minus 4 squared minus y plus 3 squared is equal to 20. Because 5 times 4 is 20. And then we will expand that. So it will become 4x squared minus 8x plus 16 minus 5 because there is negative 5. Y squared plus 6y plus 9 is equal to 20. And then after that, we will multiply this here in x squared, 8, negative 8x and 16. And then this negative 5 to y squared, 6y and 9. So it will become 4x squared minus 32x plus 64 minus, because it is negative, 5y squared minus 13y minus 45 is equal to 20. And now we will combine the same variables. So it will become 4x squared minus 32x minus 5y squared minus 30y plus 64 minus 45 minus 20 is equal to 0. And today we will combine the same exponents. So it will become 4x squared minus 5y squared minus 32x minus 30y minus 1, because 64 minus 45 minus 20 is equal to negative 1 is equal to 0. And now I will show you the standard form to general form of hyperbola, and it is vertically centered at the origin. So the equation is y squared over 9 minus x squared over 16 is equal to 1. So that is the equation, and we will put that here, and we will find the LCDs, and we will put the LCDs to the both sides, left and right. And then we're gonna multiply this here and this one here to the x. And then it will become 9 16 y squared over 9 minus 9 and 16 x squared over 16 is equal to 16 times 9. So again, we will cancel out the same numbers, like this one, 9 and 9, and then 16 and 16. And it will become 16y squared minus 9x squared is equal to 144. 144 because 16 times 9 is equal to 144. And the general form is 16y squared minus 9x squared minus 144 is equal to 0. And now, we will find the standard form, the general form of hyperbola. It is vertically at its center up, H and A. So the equation is y minus 1 squared over 9 minus x minus 3 squared over 16 is equal to 1. So just like here, we will find, or we will write first the equation, and then we're gonna multiply it when we find the LCDs of the two, and then we're gonna cancel it, and it will become 16y minus 1 squared minus 9 quantity of x minus 3 squared is equal to 144. So again, 144 because it is 9 times 16. And then next is, okay, so it will become 16y squared minus 2y plus 1 minus 9x squared minus 6 squared plus 9 is equal to 144. And then now we will multiply this 16 here to the y squared, to the negative 2y squared, and to the 1. And this negative 9 to x squared, negative 6x, and 9. So it will become 6y squared minus 32y plus 16 minus 9x squared plus 54x minus 81 is equal to 144. And then we will combine the same variables, and we will transpose this 144 here, so it will become negative. So it will become 16y squared minus 32y minus 9x squared plus 54x plus 16 minus 81 minus 144, because you transpose it so it will become negative, is equal to 0. We'll simplify rather, so it will become 16y squared minus 32y minus 9x squared plus 54x minus 209, because 16 minus 18 minus 144 is equal to negative 209 is equal to 0. This is the general form or the final equation of this standard form. We will combine the same exponent, so it will become 16y squared minus 9x squared minus 32y plus 54x is equal to 209 is equal to 0.
Hello everyone, my name is from STEM 11A. To this video, I will show you how to solve and identify the parts of the hyperbola. Orientation horizontally. We have the equation horizontally x squared over a squared minus y squared over b squared is equals to 1. To determine the parts of the hyperbola, we need to follow this. Center at the origin, vertices 0, plus minus a and 0. Foci 0, plus minus c and 0. For co-vertices 0 and 0, plus minus b. And the asymptotes, we have the equation y is equals to positive and negative b over ax. Example, x squared over 25 minus y squared over 4 is equals to 1. First, we need to determine or find the a, b, and c. We have the value a squared is equals to 25. The square root of 25 is equals to 5. Next, the b squared. B squared is equals to 4. The square root of 4 is equals to 2. So, cancel, we have the b is equals to 2. Next, to get the c squared, we need to add a squared plus b squared. 25 plus 4 is equals to 29. The square root of 29, so c is equals to square root of 29. To determine the parts of the hyperbola oriented horizontally, we should follow this. Vertices 0, plus minus 8, and 0. The value of a is equals to 5. So we need to substitute. Vertex 1 is equals to 0, plus 5, and 0. So our vertex 1, 5, and 0. Vertex 2, 0, minus 5, and 0. We get the vertex 1, negative 5, and 0. Next, we need to find the foci. We should follow this. Foci 0, plus minus c, and 0. The value of c is square root of 29. So we need to substitute. Focus 1 is equals to square root of 29 and 0. Focus 2, negative square root of 29 and 0. Co-vertices 0 and 0 plus minus b. We have the value of b is equals to 2. So we need to substitute. Co-vertex is equals to 0, positive 2. Co-vertex 2, 0, and negative 2. The equation of asymptotes, we should follow this. Y is equals to positive and negative b over ax. So substitute. Asymptotes y is equals to positive and negative. The value of b is equals to 2, and the value of a is equals to 5. So 2 over 5x. We proceed. Center at H and we have the equation quantity x minus 4 squared over 5 minus quantity of y plus 3 squared over 4 is equals to 1. First, we need to find the center. X minus 4 transpose negative 4, so we have that x is equals to 4. Y plus 3 transpose positive 3 to the other side, so y is equals to negative 3. The center is 4 and negative 3. Next, we need to find the value of a, b, and c. A squared is equals to 5. The square root of 5, so a is equals to square root of 5. B squared is equals to 4. The square root of 4 is b is equals to 2. C squared, we need to add a squared plus b squared. So 5 plus 4 is equals to 9. The square root of 9 is 3. So we have the c is equals to 3. To determine the parts of the hyperbola at the center h and k, we need to follow this. Vertices h plus minus a and k. Our center is 4 and negative 3. The value of a is equals to the square root of 5. So we need to substitute 4.
Hello everyone, my name is Justin from STEM 11A, and today I will show you how to solve and identify the parts of hyperbola vertically at the center of origin and h and k. Example number 1. Hyperbola oriented vertically center at the origin. Y squared over 9 minus x squared over 16 is equal to 1. First, we should identify the value of a, b, and c. To get the value of a, we should substitute the value of a squared. A squared is equal to 9. A is equal to square root of 9, and the square root of 9 is 3, so a is equal to 3. Next, to get the value of b, we should substitute the value of b squared. So b squared is equal to 16, so b is equal to square root of 16, and the square root of 16 is 4, so b is equal to 4. To get the value of c, we should follow this. C squared is equal to a squared plus b squared. So after that, we should substitute the value of a squared and b squared to find the value of c squared. The value of a squared is 9 and the value of b squared is 16. So c squared is equal to 9 plus 16. So c is equal to square root of 25, then the square root of 25 is 5. So the value of c is equal to 5. After we determine the value of a, b, and c, now let us proceed in finding the parts of the hyperbola. In finding the parts of hyperbola, we should follow this. To get the coordinates of foci, we have y, k, plus and minus c. To get the coordinate of vertices, we have h, k, plus and minus h. To get the coordinates of co-vertices, we have y, plus and minus b, and k. To get the equation of the asymptotes, we have y is equal to k, plus and minus a over b, times the quantity of x minus h. Now, let us proceed in finding the coordinates of foci. In finding the coordinates of foci, we should follow this. Foci is equal to h, k, positive and negative c. Since the center is at the origin, the coordinates of our center is 0 and 0. So we need to substitute the value of c. The value of c is 5. So we get this. Foci is equal to 0, 0, plus and minus 5. So the focus 1 is equal to 0 and 5, and the focus 2 is equal to 0 and negative 5. After we find the coordinates of foci, now let us proceed in finding the coordinates of vertices. To find the coordinate of vertices, we should follow this. H, k, plus and minus a. Since the equation of the hyperbola is centered at the origin, the coordinates of our center is 0 and 0. To find the coordinates of vertices, we should substitute the value of a plus and minus 3. Then, the vertex 1 is equal to 0 and 3, and the vertex 2 is equal to 0 and negative 3. After we find the coordinates of foci and vertices, now let us proceed in finding the coordinates of co-vertices. In finding the coordinates of co-vertices, we should follow these. Co-vertices H plus and minus B and K. Since the center of our hyperbola is at the origin, the coordinates of its center is 0 and 0. B is equal to 4. Now we need to substitute the value of B at the center, which is 0, 0. So, co-vertices is equal to 0 plus and minus 4 and 0. Then after that, we will get co-vertex 1 is equal to 4 and 0, and co-vertex 2 is equal to negative 4 and 0. After we find the focus, vertices, and co-vertices of the hyperbola, now let us move on finding the asymptotes of the hyperbola. In finding the asymptotes of hyperbola, center of the origin, we will have this equation. Y is equal to A plus and minus A over B times the quantity of x minus h. After that, we should substitute the value of A, B, h, and k to the equation of asymptotes. So we get this. Y is equal to 0 plus and minus 3 over 4 times the quantity of x minus 0. After we get this equation, we need to simplify it. So we get this equation. Y is equal to positive and negative 3 over 4x. Now, let us proceed in solving and finding the parts of the hyperbola center at h and k. Example number 2. Quantity y minus 1 squared over 9 minus quantity x minus 3 squared over 16 is equal to 1. Now, first, we will determine the center of the equation. The center of the equation is 3 and 1. The equation of the hyperbola center at h and k is y minus k squared over a squared minus x minus h squared over b squared is equal to 1. To determine the value of a, we need to substitute the value of a squared. A squared is equal to 9. So a is equal to square root of 9 and the square root of 9 is 3. So the value of a is equal to 3. Next, to determine the value of b, we need to substitute the value of b squared, which is 16. So b squared is equal to 16. B is equal to square root of 16 and the square root of 16 is 4. So the value of b is equal to 4. To find the value of c, we need to add the value of a squared and b squared. So 9 plus 16 is equal to 25. C is equal to square root of 25 and the square root of 25 is 5. So c is equal to 5. After finding the value of a, b, and c, now let us proceed in finding the parts of the hyperbola center at h and k. In finding the coordinates of foci, we need to follow this. H, k, plus and minus c. To find the coordinates of foci, we need to substitute the value of c, which is 5, to center 3 and 1. So the coordinate of our foci is 3, 1, plus and minus 5. Focus 1 is equal to 3 and 6, and the focus 2 is equal to 3 and negative 4. After we find the coordinate of foci, now let us proceed in finding the coordinate of vertices. In finding the coordinate of vertices, we need to substitute the value of a to the center, which is 3 and 1. The value of a is equal to 3. So we have these coordinates. Vertices is equal to 3, 1 plus and minus 3. So we get this. Vertex 1 is equal to 3 and 4, and vertex 2 is equal to 3 and negative 2. After we determine the coordinate of foci and vertices, now let us proceed in finding the co-vertices of the equation. In finding the co-vertices of the equation, we need to follow this. Co-vertices is equal to h plus and minus b and a. Now, we need to substitute the value of b to the center, which is 3 and 1. So the co-vertices is equal to 3 plus and minus 4 and 1. co-vertex 1 is equal to 3 plus 4 is equal to 7 and 1, and co-vertex 2 is equal to 3 minus 4 is equal to negative 1 and 1. After we determine the foci, vertices, and co-vertices, now let us find the equation of asymptotes, which is y is equal to a plus and minus a over b times the quantity of x minus h. To determine the equation of asymptotes, we need to substitute the value of h and k in the value of a and b. After we substitute the value, we get this equation. Y is equal to 1 plus and minus 3 over 4 times the quantity of x minus 3.
Of an nuclear cooling tower is in the shape of a hyperbola with equation. The tower is 150 meters tall, and the distance from the top of the tower to the center of the hyperbola is half the distance from the base of the tower to center of the hyperbola. Find the diameter of the top and base of the tower.
So here is our solution. The equation of the hyperbola is x squared over 30 squared minus y squared over 44 squared is equals to 1. The height of the tower DC is equals to 150 meters. Let the distance of the top of the tower from the center of the hyperbola be OC equals A. The distance of the bottom of the tower from the center of the hyperbola is OD equals 150 minus A. Given the distance of the top of the tower from the center of the hyperbola equals the half distance of bottom of the tower from the center of the hyperbola. So here is our solution. A is equals to 150 minus A divided by 2, and it will turn to 2A equals 150 minus A, and 3A equals 150, and A is equals to 150 over 3, and it will turn to 50. To find the diameter of the top of the tower, that is to find AA. From the figure, the coordinates of A are A, x50, but AX50 is a point on the hyperbola, x squared over 30 squared minus y squared over 44 squared equals 1. So what we're going to do is we're going to substitute the 50 that we get from the first part. So that will be x squared over 30 squared minus 50 squared over 44 squared is equals to 1. So the process is x squared over 30 squared equals to 1 plus 50 squared over 44 squared, and x squared is equals to 30 squared. We've just transposed this 30 squared, so it will turn to multiplication. So 30 squared times 44 squared plus 50 squared over 44, that will turn to x is equals to 30 over 44 times square root of 44 squared plus 50 squared. X is equals to 15 over 22x over 1936 plus 2500, and equal to 15 over 22 times square root of 4436 equals 15 over 22 times 66.60 equals 45.41. Diameter of the top of the tower is equals to 45.41 meters. Next, to find the diameter of the bottom of the tower, BB, the coordinates of B are x and negative 100. But B is a point on the hyperbola x squared over 30 squared minus y squared over 44 squared equals 1. So our solution will be substituting the negative 100. So that will be x squared over 30 squared minus 100 squared over 44 squared equals 1. And it will be x squared over 30 squared equals 1 plus 100 squared over 44 squared. So again, we've just transposed this negative 100 squared over 44 squared, so it became positive. X squared equals 30 squared times 44 squared plus 100 squared over 44 squared, again transposed. That will be equal to 30 squared over 44 squared times 1,936 plus 10,000. And x is equals to 30 divided by 44 times square root of 11,936. X is equals to 15 over 22 times square root of 11,936. And it will turn to x is equals to 15 divided by 22 times simplified form of square root of 11,936 is 109.25. So we've just written that here. And x is equals to 74.49 meters. So the diameter of the bottom of the tower is 74.49 meters. Hence, the diameter of the top of the tower is 45.41 meters. Diameter of the bottom of the tower is 74.49 meters. So that's all. Thank you.